Welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. Good. Yeah, so last session we stopped right here. Yeah. Okay, so we said that maybe we can move the class generation closer to the functions. Yeah. Which would be beneficial for the variables, because so let's check this type info thingy here. Type info. Yeah. Type info. Type info. Does it have any dependencies? Find or create enum by name. Ooh. Find or create. That's not a dependency, no. Create class, yeah. Main class, yeah. I mean, as long as it doesn't look up any functions or variables, it looks like it's only accessing classes. Yeah. So I think we can move it, but we can't move the vtable, right? Thunks need to be passed before vtables. Yeah. Thunks. Pass thunks. By the way, can we simplify this loop here? Can we do symbol. Basically, I would just like to simplify this if this is possible. Can we do this? Seems like it, yeah. That's much simpler. Okay, then we do this. Then we take a copy of this guy and we move it to the very first thing here. Yeah. Symbols. Yeah. Then here we keep these guys here. Then we remove the pass vtable here. So we just pass the type infos first. And we remove the type info here. Yeah. Okay, pass type info. Pass type info. Pass type infos together classes. Together class information early. And then, so we have the classes, and then we should be able to generate classes from functions. Generate classes from functions. Generate classes. Okay, and then what I think we can do, we create a new class and call it a function, call it generate class or namespace from function. and we pass a function. Okay, this one. Yeah. Then we put that down here for now. Yeah, yeah. And then we copy this stuff here, this. We need an index. Okay. Class or namespace from function. Well, in that case, we pass index t, function index. Yeah. Now this one, function index. Yeah. Okay, and then we call this function here with function index. Yeah. And that means we no longer need this here. And I think we no longer need the whole function, but let's keep it for now. So basically, we now go to this function here. So we comment out this one. And then in pass, pass fun. Actually wondering, what are we doing here? Always cause pass fun. Oh, by the way, we need to pass here the SO index. I totally forgot that. Yeah. Okay. Pass fun. Pass fun. By the way, we can also simplify this, yeah. That's good. Does it have to be here? Pass vtable. Pass vtable. Yeah, it needs classes. Probably. It needs functions. Yeah, so I guess this one, yeah, should be afterward. Yeah, should be at the end. Yeah. Pass class vtables after classes after functions are built. Yeah, okay. Okay, so we now need to pass class here somewhere. Pass fun. If it's empty. Ah, size. Right. I see. Okay. Bool empty. How about we give this here a name? Const bool function. Let's say a fun end. If fun end. It's always good to have like a name. There we go. So that's a fun end. And let's put the same in here. If not fun end, then it's easier to understand, like, okay, what does it actually mean? It means fun end. Or let's say fun block end, maybe. Fun block end, I think that's better. Oh man, so much code already. Fun block end. Okay, good. So we pass a type info here, and then we pass a function here, and then inside here, I would say we put it here. We say if not. Oh. Oof. Oof. If not fun block end, else. And then here we put generate class or namespace from function, and we pass the fun index. And I think the assumption here is assert. Wait, maybe we can put the assert in here. In this. Yeah, here the assumption is assert function index is not invalid index. There we go. Yeah. Okay. I think this may work. Okay, let's put a breakpoint here. Let's put a breakpoint here and generate classes from functions. Let's put this back for now, and instead let's put here let's do the following just for testing. Basically we expect assert is class or is namespace, right? That's what we expect now. Right. Okay, let's see if we get any problems. Hopefully not. Hopefully it's all good. Good. So. Da, da, da. Let's put a breakpoint in here. Okay, so. Samba. Oh. Ah, okay. Let's put a breakpoint in here. Class name. Overridable. Type info. By the way, we can make this const here. Yeah, we should probably make it const. Or maybe it already is const. I don't know. Maybe, maybe not. Let's make it const. Yeah. Type info. Const. It already returns a const. Because this is probably const, right? Const, yeah. Okay, I think what this means is we can remove the const again because it's already const. Yeah. Okay, anyway, this looks successful to me. So next step, pass fun. Oof. Oof. Okay, what do we got here? 0. Oof. Actually, the expectation is that they are matched, right? Yeah. Okay, good. So block end is false. So it goes in here. Fun index 0, let's say. It's not invalid index. And we get a function and nothing to be done here. Let's put a breakpoint in here. Yeah. Yeah. There we go. Is namespace false? Is class true? Yeah, okay. Then let's put a breakpoint here. And we got an assert. Uh-oh. Oof. Okay. Oh. What does that mean? Pass fun. And the index is invalid? Okay. Pass fun. What is the symbol? Oh. Right. Right. If pass fun. Index. Yeah, let's do that then. Yeah. Okay, and then it gets in here. So what do we got? Function index. It's MachTool set cursor ID, which is a function, yeah. And MachTools. It's either a class or a namespace. Okay, it's a namespace. Yeah. Okay. Okay, that means we should be able. We should be getting now the classes or namespaces built very early, right? Yeah. By the way, do we also? Do we also need to add a class or the name space? Do we need to add a class? Here we could add a class. to a source file, but I mean, we have the functions. From the function we get the class. I don't know yet. Right now, I think, let me see, in source files, source file, where is it? Here, it has function variable. It doesn't have classes yet. Yeah, I don't know if we need this. Maybe not. Well, we can get the class from the function. Yeah, I don't know. Yeah. Good. Then class, what is it? St show cursor. Struct show cursor. Okay, so we got this. This looks good. And then that means we can now, in our variable, by the way, let's run this through and see if we get this assert here hit. Oh, we get some other assert hit. Oh, what is this? Huh? W? V? What is that? So W somehow has been demangled as W chart T. Huh? Okay. Oh, that is unexpected. That is unexpected. Good that we put an assert. Oof. I don't know why the demangler does this kind of thing. A W turns into a W chart T. This to me looks like a really far stretch. I mean, it's perfect. To me, it looks perfectly plausible to have a variable with the name W, right? I think demangled names, don't they always start with, well, not always, with underscore. Okay, that is unexpected. That is really unexpected. Huh. That is unexpected, yeah. Oof. By the way, we can certainly remove this debug here in this one. We can also remove this. Yeah, I don't know how to say here. How do we elegantly avoid this? We could say don't only demangle if it starts with an underscore. Or we could say we explicitly... Can we search for wchart here? UVW B C A H S. Okay. Are there any more of these kind of symbols? Let me put here if demangled is not that, then int a equals 0. I would like to see if this is the only one or if there's more than one. The problem is you can't skip asserts. So this is a dead end assert, I think. Or is it not? I'm not sure. Is there an ignore button for assert? Or skip? Let me see. So this one, and there's another one. Oh. Yeah, okay, but if there are only two, then to me this, so WH probably means a width and a height. Yeah, that's probably the meaning. Yeah. Okay, okay, how do we deal with this thing? Oh, well, we could say it has to start with an underscore. Yeah. By the way, where is it? Yeah. Yeah, we could say it has to start. Yeah. If it's really weird, I have to say. Titanium demanga. Sage. S. I'm a bit surprised that Itanium demangle, does it not check if it is actually? It doesn't. Wasn't there a function? Demanga. I thought there was a function here. Is Itanium encoding? Ah. One to 4 leading underscores followed by Z. Is Itanium encoding? Yeah, maybe we should demanga is Itanium encoding. Okay, how about we make a copy of this and for starters, we just put it up here. Let's put it up here. By the way, I just realized that these functions here should be put higher up. Yeah. All these functions here, they should be above here. Yeah. Okay, so is Itanium encoding LLVM Itanium demangled. Let's say mangled Itanium demangled. Yeah. Let's say if not is Itanium demang, then return empty string. Yeah. Otherwise, we do demangled equals that. If demangled equals null pointer, mangled name, and then we do here LLVM Itanium demangle. Okay, this looks, it looks okay, apart from maybe the naming. Let's adjust the naming. Mangled name. Demangled. Well, let's shorten this to mangled. 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 Pos. And red. Okay, this looks good. Itanium demangle. There we go. Is Itanium encoding? There we go. Okay. Okay, and then we go to Titanium. We search for all occurrences of this. And we replace. There's not so many. So we replace demangled. Demangled. So we say demangled equals Titanium demangle mangled. Okay, and then we say if demangled dot empty, then we assign mangled. Yeah. This looks good. And then we can do the same here. Titanium demangle. By the way, I'm just realizing that this one is leaking, isn't it? Yeah, we never free. That one is leaking. Yeah, I didn't care to std free this buffer here, right? So this one is actually leaking. Interesting. Mistakes are made. Okay, but it's fixed now. Look at that. And it's also much more beautiful. Okay, class name. Yeah. Let me just copy paste this thing. Yeah. This one is thunk name. Okay. Okay. Okay, and then Titanium demangle. This one is also leaking here. Look at that. Let's also call this one here CSTR mangled. Yeah. Okay. Well then, return. Yeah. This one has to allocate the string here, and then here's another allocation and another allocation. So this is 3 allocations, this call here. Yeah. It's 2 to 3 allocations, this one. So we don't care. We don't care. Good. Any other Titanium demangles? Maybe not. Good. And we fixed the leaks as well. That's good. So there shouldn't be any of these left here. Just this one, right? Yeah. Yeah. Good. So we have demangled. And now I expect that we no longer hit this here, right? Yeah, because now we only demangle if it starts with 1 to 4 underscores and a Z. Yeah. Yeah. Mm-hmm. I wonder if we run into any other problems then. Well, we will see, I guess. Okay. Okay. What do we have here? This one is empty. Okay. We didn't hit that before. Okay, let's put a breakpoint here. Overridable. We did something wrong. Maybe. So class name, binary type info, symbol. So we are looking at overridable. It starts with an underscore, 2 underscores and a Z. Let's go in here. Data, CSTR. Huh. Okay. So it does not. Oh, okay. Okay, so it looks like here we should not use this here. Oof. Okay. Well, okay, then here we use demangled CSTR. String is not starting with underscore Z. String is not starting with underscore Z. Okay. Then here we say assert demangled equals true. What, just assert, no, not null pointer, there we go. And then we do this here. Return demangled free. Okay, let's try this. Oh boy. Oh boy. Oh boy. By the way, do we really need to pass? Let's see. Yeah. We could it doesn't matter. It doesn't matter. Good. So this now, let's see what it does. CSTR overridable, demangled overridable, and demangled return free return class name overridable. Yeah, okay, that seems to be correct now. Okay, now we are here And so these are the same. And let's remove this breakpoint, and it does not hit anymore. Okay, and now we see this check here. So one of these is expected to always be true. And that has passed. Okay. Good, that works. I think we no longer need this thing here. Yeah. What do we? I don't think so. Do we? Like a verification. Probably not. Just remove it. Good. We comment this out. And we comment this out. And so we have generate class or namespace from function. Yeah. That's called here. Yeah. Well, maybe it builds process details. Yeah. Well, maybe. I mean, what we did in here is not too bad. Have some verification. Yeah, I mean, it doesn't hurt, right? So we can have a build base class verify. Build base class. So we can have a bool verify verify class and name spaces. Verify base class links. Verify class and namespaces. Okay. And then here, make a new function. There we go. There, and then here we take this stuff here, and then we comment this out, uncomment, and then we do functions, function. We simplify this to function const verify. By the way, can this also be const? Can be static, no? Yeah. So here we say functions, and we can remove this, and then we can remove that, and if not that, then we check that, and then assert, and then we do Verify class and namespaces. Boy. Verify class. Let's do asserts is namespace or is class. Maybe unused. And bool verify functions function. Namespace is class. Okay, but then it's a function that the nice thing about this one here, it verifies here in an assert. This one does not. Verify base class links. Can we have assert in asserts, or would that break things? Asserts. What probably works. Assert and that's what. Nested assert call. C++, nested assert call. How about we, let's say here return true. Return if not that, then return false. Set match count. How about we do const size t error count 0 int int error count 0. If not that, then plus plus error count. Return error count equals 0. Okay. Not const. Okay. And then we put this guy, we put him here, here. Verify class and namespaces. Let's say generate. Let's take this comment here. Put this here. Generate classes from functions because not all classes have RTTI. Classes have RTTI, yeah. Verify that all classes and namespaces, well, verify that all function contexts have been created. Okay, and then let's try wrap this here into an assert. And just to test this, I would like to put in here assert, and I would like to put for testing, let's say bool is class false, and then we should hit an error, right? Let's test this. Assert, okay. And then we should hit assert now, yeah. And it's in here. Yeah. Okay. And can we step over it or not? Oh, it quits. Look at that. Wow. Well, that's interesting. Okay. Well, looks like we can have assert inside assert. Maybe. Or can we not? Let me see. Can we actually skip an assert? Let's see. Ignore. Oh, it just quits then. Huh. Interesting. Oh, yeah, it was error code, yeah. It's kind of weird though. W assert. It does something in there. Yeah, we're just using standard assert. It has some determined functionality. Okay, so we expect this and this, error count, blah, okay. So if we comment this and this, then this should succeed, right? Yeah, okay, let's put this here. Let's run this. And Yeah, good. It's passed. Okay, cool. Then we have we have everything prepared for the next step, which is here. We can put this assert back, and we can remove this. So that is fixed. Then we can remove this one here. Do we actually need to assign mangled to demangled? Mangled, pinned, maybe. So if this is empty, full variable name. Yeah. Demangled. Yeah, I guess that's the easiest. Yeah. Here we could assert that demangled is empty. Yeah. Yeah. So if we were to remove this, then we could here say assert demangled.empty, and then we could assign mangled here. Right, that would be the identical thing. Expects no mangled name. And then here we would say demangled. So that could be empty now. Oof. That could be empty, no? String view, std move. Demangled. Mangled. Okay, so here basically the name, the demangled can be empty or not empty, right? Here, now, right? Let me put a breakpoint here. Let's take a look at this. So it's outside a without context. Okay, so demangled is empty now, and mangled is that. Yeah. So Yeah, so let's put an assert here. Full variable name is no, not empty. There are too many asserts and too little, huh? Shorts. Good. And then here we say std string name equals if demangled.empty, then we take mangled, otherwise demangled, and then here we put name, and here we put this name. Okay, let's try that. Yeah. Okay, so name is, because this is empty, short, full, no, name is empty as well. What mangled is name, mangled. Yeah. By the way, can't we just, we can remove this here, I think, right? Make it simple. Good. Yeah, okay, this looks good. Name. Let's see some others. Demangled. When do we get some demangled here? Simple. Do we ever get one here? That's a good question. Huh? So far, function index. Let me put a breakpoint here. If demangled dot empty, not empty, int a equals 0. Let me put a breakpoint. Does it actually? For what does it hit? I suspect it does hit, but I already forgot. Like for something in a class, no? It should hit. A variable in the class should hit here, right? If that's the thing. Yeah. There we go, yeah. See, stream sound, that's a class. Yeah. Yeah. Okay. That looks correct, short, full, yeah. And yeah, and then here we need to do something about the class or the namespace, yeah. Okay, but I think that's good enough for this session. Then let's continue here in the next session with this. Oh, things getting complicated here. Good, but it looks promising if we didn't make any mistakes. But I think it still works. We did quite a bit of refactoring here, but things look relatively clean, so that's good. Yeah, looks relatively clean. Good, yeah, next session we continue here with this to do. Try to figure that out. Basically, we want to assign the variable to the correct thing, right? So it either belongs to a function or to a class, or it's in a namespace, or it's in a source file, right? These things, right? Yeah. But well, on that note, it is Oh, no, it's fine. It's fine. Good. Then I think that that's it for this session. Yeah. Good. Then I hope you enjoyed. I wish you a great day or night. Until next time. Goodbye.